Welcome to the WANdisco Fusion lesson on Fusion and the cloud. What is the cloud? Today, pretty much everybody, organizations including individuals, have used some type of cloud technology. Whether it's something that's retail that you use in your personal life, or whether it's something that an organization uses, the cloud is becoming more and more prevalent in today's computing architecture. Essentially, infrastructure, platform, or software as a service makes up the cloud. Each tier hands over more responsibility of the stack to the cloud. A typical on-premise IT environment would have all applications, databases, operating systems, hypervisors, physical servers, storage, and network. All of that is managed in a data center by the organization. That's your traditional IT on-prem architecture, which was very prevalent in yesterday's organizations up until the last maybe 10 or 15 years. If you go back 20 years or so, or 30 years, pretty much everything was run in an on-prem fashion, and everything was developed by a team of developers, database administrators, network engineers, hardware engineers, storage engineers. They all managed the large infrastructures. Many companies had several databases, several operating systems, and several data centers that may span the globe. Infrastructure as a service is handing off more of the computing and the physical environment to the cloud. In infrastructure as a service, you'll see the hypervisor, physical server, storage, and network being taken care of by a cloud provider. And then the applications, the databases, and the operating systems are still installed, configured, and managed by an IT organization, but the infrastructure is now managed by someone else. And there are great savings with that. You save a lot of space, you save a lot of resources for managing the physical servers, the storage, and the network. Platform as a service takes it one step further, where the database and the operating system are also managed by the cloud. And the only thing that the platform as a service users do is install their application into the cloud environment. This usually involves provisioning an environment that will have a database on it, that might have an application server on it. All the operating system and networking, physical server, storage is pretty much transparent to the platform as a service user. This is very common, and this even saves more time on the configuration of applications. So the standard configuration of software that goes along with the platform is already in place. And there's huge time savings when you need a provision an environment, for example, that requires a SQL database and an operating system and maybe an application server, where you just provision that environment and very quickly you could install your application into it. Software as a service is the situation where everything runs in the cloud. That means the application, the database, the physical storage network all run in the cloud, and you access it as if you were accessing a utility. Common examples of this include applications. Salesforce.com is a very popular one, but there are scores of applications and systems now that are provided as software as a service. And the huge savings there is that you take your IT infrastructure team totally out of play, and you just manage the application as it were a service. And huge savings for space, physical servers, provisioning, environments, capital expenditure versus operational expenditure or OPEX. Huge savings here, but the price is still there. You still have to pay some type of monthly fee, monthly service charge to use the software as a service, and that could become expensive also. Pros and cons for the public cloud. The pros are nearly instant deployment. No waiting for the IT department anymore. A typical use case could be if somebody needs to provision an environment with a database and an application server to quickly test something out. Instead of going out and requesting IT, find physical servers, configure that on a network and install all the appropriate middleware and software, and wait maybe 2 weeks, 3 weeks, 4 weeks, 6 weeks, or months, you can provision it nearly instantly, and within 20 minutes, maybe even less, you could be working in your environment. Instant infrastructure refreshes, so updates to your operating environment, version upgrades, etc., can all happen behind the scenes and can save a lot of time. Availability of backup monitoring and tuning, all offloaded. That is taken care of and you don't have to worry about that. Functional consumption, and this is a little bit relating to the service type situation, a software as a service also. You could do pay as you go. It's very good for unpredictable and highly variable workloads, and it supports that moving from CapEx to OpEx. Typical situation, I need to quickly spin up an environment to run some type of test or get some type of analytics results. I get my results and I take it down and I only paid for what I used. Some cons though, on the other hand, are predictable or high workloads, very heavy workloads, might not be as cost effective. I could think of an example of the mainframe environments that have been running for many years in a company and they run a good portion of the company's business. Those might not be good workloads to move to the cloud per se. Applications that require very low latency between the client and the server. This could also be a situation if you don't have very good bandwidth between your customer location or your organization's location and your cloud provider, that latency can become an issue. Data locality, some laws and regulations may require your data stay local or stay on-prem. The cloud sometimes isn't very good for that, although that's improving quickly. Security in general, you'll still see organizations that manage secure data, personal identifiable information, that might be reluctant to move data into a public cloud. That's still ongoing today. And sometimes for specific and critical SLAs, the cloud might not be able to provide exactly what is needed for an organization. The next subject is, what's the difference between public, private, and hybrid clouds? In general, a public cloud is a cloud service provided from shared infrastructure. That means the infrastructure that's being accessed, everybody uses that same infrastructure. And you don't really know that it's being shared other than someone telling you that. And you shouldn't really care as long as your performance is good and your application operates in the manner that you signed up for. The private cloud is a cloud service hosted and provided to an internal organization. It's internal to your organization, but it has some of the characteristics of the cloud. Hybrid is running a service or a data set between a private infrastructure, commonly referred to as on-prem or on-premise, and a public cloud. But the important thing to note here is that hybrid cloud doesn't have to mean the use of a private cloud for the on-prem element. It could be the regular old traditional IT and that integrating in with a public cloud. Definitions do vary, so if you're having conversations with prospects or customers, keep in mind that their description of hybrid and private cloud might be different from yours. Private cloud isn't just advanced virtualization. It's not just saying, I'm going to take these 15 or 20 servers that used to run these applications and virtualize them all and have them run in virtual machines on one big box or 3 big boxes. It's typically considered private cloud if there's some type of provisioning automation, meaning just like in your public cloud where you could go and provision a service to do some testing or analytics on, and you could do that quickly, service. It's a user self-service type situation, and also the ability to mix and match resources. No separate clouds for slow disk or fast disk. It's just the ability to provide the service, to provision the service, and to be self-service. That's typically what a private cloud is. But it doesn't stop organizations or groups from relabeling their virtual stack a cloud stack. That it will go on. The key point here is that when you're having these conversations about a public, private, or hybrid cloud, just remember definitions vary. What is cloud object storage? Object storage is not equal to a file system. In some instances, it may appear to look like a file system, but it's not. It lacks the POSIX features such as append. There is no folder hierarchy in cloud object storage. All files are stored in a single flat namespace. And the data could be of any format. So for example, you can put comma-separated files in for reporting, for running queries against. You could put movie files, JPEG picture files, all sorts of file, any type of file can be stored in object storage. Now, one point on the folder hierarchy, it might look like there are folders and hierarchies in some object storage platforms. For example, AWS S3. Those are really prefixes in front of the file name. AWS S3 makes those look like folders and give the appearance of a hierarchy, but other cloud object storage platforms will just have those as prefixes in front of the file name. For example, /sales/2018 as a year might be a prefix, and then all the files with a name after and with that same prefix. It might appear in AWS as a folder structure, but in another cloud object storage, it just might look like files with those slashes and those prefixes in front of the name. There's definable metadata, meaning that you could embed metadata along with the object that can be searchable, and that's very powerful in being able to look up and structure your system or your cloud object storage for optimal, not only performance, but optimal searches. There is a unique identifier for the container/bucket in cloud object storage. There is encryption, access controls, lifecycle policies, and versioning. And it's an eventual consistency model across the infrastructure. What that means is that when you put a file in the cloud object storage, upload it using some type of API, it will eventually be consistent. It's not the strong consistency model that you'll see with some type of database technologies. Just remember that when you're especially working with larger files or you're uploading many files into an object store. How does Hadoop in the cloud work? The Hadoop cluster on demand is a platform as a service. Equivalents include Hortonworks for AWS, Google Dataproc, HD Insights on Azure. They can be spun up very quickly. You define a cluster, wait a few minutes, run a job, and stop. In some instances, they're used like an ephemeral bursting technology for processing. It uses the local disks for the Hadoop data, for the HDFS data. And then the question is, well, if it uses the local disks for HDFS, how's the data persisted? It has to be written to something to persist the data, such as Swift or AWS S3 before shutting down. Thus, the clusters have the classes set for access to the relevant object store. And that's the key point there. Private cloud technologies and fusion. Multiple vendors are adding object store APIs to their existing storage offerings. Most common are Amazon's S3 and OpenStack Swift, but more are coming along. It's quite common to see object storage and private cloud technologies today that are based on Amazon's S3 API. API compatibility can vary, and you have to check with the individual documentation to see if any of the features are missing. Fusion. WANdisco Fusion uses the HTTP/HTTPS interface to the object store. This means that Fusion can also address on-prem storage as either a target for continuous replication or a source for repair-based scheduled replication. And how does Fusion add value? Well, migrating big data to the cloud for a DR backup or workload offload situation is a good use case. It enables hybrid cloud, and migrating data between cloud vendors is another area where Fusion could add great value. How does it do it? Continuous replication can occur from an on-prem cluster to an object store. That could be Hortonworks running on-prem. The data that's loaded into HDFS gets updated continuously to an AWS S3 bucket. It keeps that data relevant. It allows for high volumes of transfer to keep up with the ingest rate, and it minimizes WAN spikes, common with periodic copy-based replication methods. It works with existing Hadoop and network security, and updates to the data in the cloud can be pushed back very easily. It's an example of replication to object store. Fusion will be deployed on a persistent virtual machine in the cloud. Marketplace templates automate this. For example, in AWS, there will be a marketplace CloudFormation template that will install Fusion. For Microsoft, it will be an Azure app that will install the Fusion app and will install Fusion into the HD Insights app. And these automate this task. And then the next step is, once you have your Fusion node sitting up in a cluster that's an object storage installation, you will induct that on-premise node to the Fusion server that's running in the object cloud store. The on-prem HDFS clients replicate continuously to the object store. So you can see in the diagram here, any write that happens to the cluster that's intercepted by Fusion will automatically get replicated up to the object store. No requirement for cloud credentials stored in an on-prem and the on-prem configs. Replication from the cloud using compute clients. This is the burst out activity that was mentioned before. In a situation where you want to do burst computing, meaning I'm going to set up this Hadoop cluster and have it process a load for an immediate burst, that's the situation we're working with here. It uses an object store as the primary or secondary storage, and cloud-specific clients for different cluster types are available. For example, Elastic MapReduce for AWS and HD Insights for Microsoft Azure. And though, for example, the Microsoft Azure situation, the HDI app will be installed, and then the client libraries will be present on that HD Insights cluster. And as activity happens in the HD Insights cluster, that can be replicated back to another cluster in Azure or an on-prem cluster. But it's important to remember, without that, the active replication, live replication, is one way. It's from on-prem to the cloud object storage. This does allow the active live, what we call live replication with on-prem. In our definition, this is a true hybrid cloud environment. Installing Fusion with an object store. Specific cloud packages, as mentioned, are needed. This is an example of Fusion Swift, but you need Fusion EMR, Elastic MapReduce, if you want to install into AWS, and you need the Azure HD Insights app to install into HD Insights on Azure. There is a Fusion client for both of these technologies I just mentioned, and the Fusions are deployed by marketplace templates, CloudFormation templates, and apps in Azure. The Fusion servers use an installer-created core site XML to reference the storage, the object store. Some tips regarding installing Fusion with an object store. Make sure you use the appropriate object store release of Fusion. Ensure that the DNS on the object node can resolve the bucket URI. That's very important. And the next one is maybe even more important. Ensure that the object store node can access the bucket using the native client. In an AWS example for S3, you would want to install the S3 API on your node and ensure that you can do an S3 API command to access that object store, like a simple put object, list object, to make sure that you have no issues connecting with that object store. Ensure that the Fusion processes run as a user that is an on-prem cluster super user. You can tune the core site XML for best performance transfer rates, and to use the unidirectional networking feature if you have restricted on-prem environments. Here's an example of what the configuration might look like and for the installation in a Swift environment. And here's what the credentials might look like, these service credentials. These can be for S3 compatible object stores or Swift compatible object stores. All of them will have some type of credentials where you could set up this access. A newer technology that Fusion provides now is LiveData for object stores. This would be a case where you're going from an S3 compatible bucket to another S3 compatible bucket. It could be for multi-region, multi-cloud. That could be between an AWS cloud and an S3 cloud and another object storage that's S3 compatible. This could improve performance, improve availability for the data that's stored by your application, and might be able to meet some regulatory compliance needs with regards to geography. In this case, the client, as you could see here, is making a call to update the S3 storage. With the live S3 proxy, the Fusion proxy intercepts that. The client is directing it to the S3 proxy URL, and that's where Fusion takes care of the agreement with the other side, the Fusion server that's managing the replication for the other S3 bucket. The Fusion allows the write, and then the Fusion server will do the upload of the object to the other side and keep it in sync. The key point here is that it's a proxy. The S3 API call references the endpoint of the S3 proxy in this case. There's a virtual bucket concept that is implemented by WANdisco Fusion, where you could have multiple virtual buckets, meaning that a virtual bucket here for this S3 compatible storage will tie to this virtual bucket for S3, and it can be configured for as many buckets on each side as needed. A virtual bucket can map to any bucket in any region, and there are exclusion and inclusion rules to limit what gets replicated and is available for replication. It provides live data coordination for the object cloud storage itself. No compute stack is needed, and it can be used with any API compatible with the backends, meaning in this example, any S3 compatible storage that has an API for it should be able to work with WANdisco Fusion live data for object stores. And in this example here, it's the live S3 proxy. This concludes the WANdisco Fusion lesson on Fusion and the cloud.